permutations where objects are identical. So if we look at the four letters A, B, C, D, and the arrangements, distinguishable arrangements, right? A, B, C, D, A, B, D, C, A, C, B, D, etc., right? How many ways are there? So four letters can be arranged 4 factorial ways, or 4p4, which is 24. And we have 6 columns with 4, right? So each of these is a different arrangement. How many? 24 as a factorial, 4 factorial. Now, what if we replace all the B's with an A? Then here are our 24 arrangements. And here we've got AACD. And here we've got another AACD. Any more AACD? No? Like here we have ACAD. Change its name now, right? Like University of the Arts. Is there another ACAD? There's another ACAD. So how many different arrangements are there? So those two are the same. Those two are the same. ADCA. ADCA. So how many different arrangements are there now? So there were 24 different, and now what? How many different arrangements?
12?
Yeah, 12, right? Sorry, that goes with that. So how many different arrangements? There are 12. Express this value in factorial notation. Well, we can't write it as a factorial, right? But we could say, well, if we had the 4 factorial ways, which is 24, how are we going to get 12? What are we going to divide by? 2. And actually 2 factorial, right? 2 factorial. All right, what if you take this and replace all the C's with A's? So now we have AAAD instead of ABCD. And I want to say, okay, well, how many AAADs do we have? There's an AAAD. There's an AAAD. Any more? Above there. That one. And one to the right. Ooh. Another one in the first row. All right, so how many of these do we have? 1, 2, 3, 4, 5, 6. Any others? 4. All right, so if 6 of these are the same, so for the 24 arrangements we now have like these 6 the same, and in our AADA, so there's probably 1, 2, 3, 4, 5. There's 6 of those. So how many different arrangements do we have? It's only 4, right? One way to think of that is, where's the D? So either the D is in first place, or the D is in second place, in which case there's 6 of those, right? Because the rest of them are A's, or the D's in, it's either in first place, in second place, in the third place, or it's at the end. Okay, so there's only 4 ways that can happen, all the rest of the letters. Express this in factorial notation. Well, again, we don't have any. So if we started with 4 factorial, all the arrangements, how are we going to end up with a 4? What are we going to divide that by? So 24 divided by what is 4? And 6. So how do we do 6? 3 factorial. So here's how it works. The number of permutations of n objects, when A of them are identical, B of them are identical, etc. So it's n factorial, right? It's all the ways that we can arrange it. And then we divide by A factorial, B factorial, and so on, where those are identical. Right? So if we think about it, the reason up here, why are we dividing by 2 factorials? Well, there's now 2 A's. One of them used to be a B. So AB, everywhere there's a BA, that's the same arrangement. right? And we can't tell that apart. Like if this was A1, A2, and this one was A2, A1, then we can tell them apart. But since we can't tell them apart, we divide by, well, there's two A's. So we'll divide by 2 factorial. Or now, there's 3 A's, so we divide by 3 factorial. What if I changed all the D's to A's? All we would have is one arrangement, right? They'd all be A. So, given the letters in the word mathematics, how many different ways can the letters be arranged? So, first step, how many letters are there? We've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So 11 letters can be arranged 11 factorial ways. If they were all different, that would be the answer, right? Because we could tell every arrangement apart. But we have 2 M's. So we divide by 2 factorial. Because we can't tell the difference between them. So in every arrangement, if it starts with an M and ends with an M, we don't know which of the two, first M, second M, vice versa. We divide by 2 factorial. We got 2 A's. We divide by 2 factorial. We got 2 T's. We divide by 2 factorial. H, E, A is already done, I, C, S. So how many different ways? 11 factorial divided by 2 factorial, 2 factorial, 2 factorial. So on the calculator, we could do this. So 11, math, over to probability, number 4 is factorial, 11 factorial, divided by, now if I want to do them all together, I'm going to have to put a bracket down, right? Because we're going to have to work out 2 factorial, 2 factorial, 2 factorial. 2, math, over to probability, 4. And I could just put this one right beside it. So 2, math, over to probability, 4. And then 2, math. So it'll just multiply them together. It knows what to do with that. And we end up with 4,989,600. Okay, as compared to just 11 factorial, right? Like 11 factorial. So if they were all different letters, not the one, they were all different letters, there would have been 39,916,800, right? How many different ways can the letters be arranged if the first letter must be an S? So here's how I think about this, right? I'm just going to write all the letters out again, mathematics. I can say, all right, so the S is gone, right? We're putting it on a Scrabble board, we got all those letters. Yes, it's on the board. What's left? How many letters are left? How many of them are the same? Well, there's still 2 M's, still 2 A's, still 2 T's. So it's going to be 10 factorial divided by 2 factorial, 2 factorial, 2 factorial. Which is, I'm just going to go back up here and grab that and bring it down and go over and change the 11 to a 10 and get 453,600. So we're dealing with restrictions, right? And there's, in a sense, inbuilt restrictions when there's that repeating letter, right? Which says, oh, okay, so take all the arrangements and then divide by how many times that letter is repeating. What if the first letter must be an A? Okay, so again, mathematics. Take out an A. How many letters are left? 10. How many are the same? Well, there's 2 M's. There's no longer 2 A's, right? That A is gone. So there's 1 A, so we don't put anything. But there's 2 T's. So 10 factorial, 10 letters left. 2 of them are M's. 2 of them are T's. And so, let's see. can go grab this, take out one of the two factorials, and go 907,200. So more arrangements than if the first letter is an S, right? If the first letter is an S, then we still have those two A's floating around. If the first letter is an A, then we no longer have repeating A's, or we just have the repeating M's and repeating. All right, any questions about math and that? A hockey team has a record of 6 wins, 4 losses, and 2 ties in 12 games that they have played. How many different ways could the order of these results have occurred? So one way to think about this problem is, you can say, well, there's 6 wins. 1, 2, 3, 4, 5, 6. 4 losses. 1, 2, 3, 4, and 2 ties. So you can think of this sort of as a word, right? I need to arrange all of those letters, right? How many ways can that be done? Well, okay, wait, there's 12 games, so 12 factorial. But how many are the same? So 6 W's, right? Can't tell them apart, so 6 factorial. Anything else the same? 4 losses, so 4 factorial. And 2 ties. And that is, so let's go back up here. Change that to a 12. I'm lazy, I don't want to type it in again. And 6 factorial, whoops, 4 factorial, 2 factorial. Right, so just think about wins, losses, ties, right? Well, it's like letters. We can make it like a word consisting of 6 W's, 4 L's, and 2 T's. And we get 13,860. 13,860. The textbook room in the Learning Commons has a bookshelf with 5 identical chem clears. So remember, identical objects, right? So yesterday was they were all distinguishable. We could tell them all apart. Today there's identical. 5 identical Chem 30, 8 identical Math 30-2, and 10 identical Bio 30 books. How many different ways the 23 books can be arranged on the shelf? Okay, I'm going to pause. You work it out. So we're arranging 23 items, 23 objects, right? So 23 factorial, but 5 are identical Chem. So 5 divided by 5 factorial, 8 identical Math 30-2, and 10 identical Bio, and this gives us what number?
1,472,412,942.
All right, so let's just say lots. There's a lot of different ways, right? A lot of different ways. How many arrangements of the letters in the word puppies are there if there are no restrictions? Okay, so we have 1, 2, 3, 4, 5, 6, 7 letters. Now, no restrictions, there is an inbuilt restriction, which is the fact that we have what? 3 P's. Your puppies, there's a lot of P's. So we can't tell the order of those 3 P's, right? So 7 factorial divided by 3 factorial, which is, how much?
840.
840. I was getting there. I would have got there, I think, maybe. Each arrangement begins with the letter P. So every time I do one of these, I do that. I throw the letters down there, right? So, okay, if it begins with a P, get rid of that. It's gone. What's left? How many letters are left? 6. It can be arranged 6 factorial ways. How many of those 6 letters are the same? 2, right? We have 2 P's. All right, I know this one. It's 360, right? What if the first two letters are P? Okay, again, let's write it out. P, U. All right, first two, okay. They're gone. What's left? 5 letters. How many are the same? 5 letters, none are the same, can be arranged 5 factorial ways, or 120. What if all the P's have to be together? Okay, so this time I'm going to write out the letters, but I'm going to put the P's together. So I imagine that the 3 P's are on one tile, right? They're just glued to one big Scrabble tile, and all the other letters are on their own little tiles. So how many tiles do we have? 5. How many ways can we arrange these P's? Just one way, right? You can't tell them apart. I mean, it's 3 factorial ways, but then you divide by 3 factorial, so just one way. So in essence, what have we got? We have 5 objects to arrange. None of them are identical. So just 5 factorial. The first letter is a P, and the next letter is not a P. Okay, so P, U, P, P, I, E, S. Okay, that's gone. We have 1, 2, 3, 4, 5, 6 things to arrange. Okay, so the first letter is a P, the next letter is not. How many choices do I have for the next letter? 4, right? There's 4 letters, so here we go. This is a P, whatever, cross it off. So not a P. Okay, so let's just arbitrarily take one out. How many letters are left now? 2. One more time. Count again. So 5 factorial, but, or and. I know, I'm going to make a 5. I'll fix it. Can't fix it. But of those 5 letters, what do we got? 2 P's. So we divide by 2 factorial. And that is, how much? Really? No. 240. Now, here's another way to think about this, right? So if the first letter is a P and the next letter is not a P, then, okay, so each arrangement begins with the letter P, right? We know there are 360 ways that it begins with a P. But these 360 could begin with 1 P, or 2 P's, or 3 P's, right? That's all part of the 360. The first 2 letters are P. We know there's 120 ways. Now, if I want the first letter is a P and the next letter is not a P, then I can take the 360 that begin with a P. From that, subtract the ones that begin with 2 P's. And what's left is the ones that will begin with exactly 1 P. Okay, so 2 ways to think of the problem. We can do this. Or we can say, wait a sec, I know there's 360 of them that begin with 1 P or 2 P or 3 P. And I know there's 120 that begin with 2. So if I take all the ones that begin with at least 1 P and subtract the ones that begin with 2, what's left? The ones that begin with exactly 1 P, which is this. Okay. So you can do those either way. Sausages. This puppy is like sausages. Find the number that begin with 2 S's. All right, so write out all the letters. Cross off 2 of the S's. How many letters are left? Are there any repeating letters? 2 A's. Any other letters repeat? No. 6 factorial divided by 2 factorial is 360. Begin with exactly 2 S's. All right, exactly 2 S's. So we could do this. Say, all right, S-A-U-S-A-G-E-S. Cross that off, cross that off. So our next letter could be what? We got a problem here. If our next letter is an A, well, then there won't be any repeating letters. Okay, so let's do this. This is an A. Okay, so we put an A in there, right? So then an A is gone. And what's left? Okay, we don't have the S, right? So the second letter can't be an S. But if it's an A, then what's left? 1, 2, 3, 4, 5. So that'll be 5 factorial and no repeating. Okay, so this is, second letter is an A. Second letter is A. But the second letter could be not A, neither A nor S. Neither A nor S. So that means the second letter would be a U, a G, or an E. Yeah.
Would it be the third letter if it's starting with 2 S's?
So, oh, sorry, yeah.
Oh, okay.
Third, you're right. Third. All right, we can fix that. Third letter. Okay, third letter. So the third letter is neither an A nor an S, so put that back in, S-A. Okay, so we've gotten rid of the 2 S's. So not an S, not an A, there's 1, 2, 3. 3 choices. And then what? All right, let's just take out one of those letters. And we are left with 1, 2, 3, 4, 5 letters, but 2 of them are A's. So 5 factorial divided by 2 factorial times 3, that's 180, which is going to leave you 300 ways. So it begins with exactly 2 S's, and the third letter is not an S. But there's another way. So sometimes in these units, it's easier to count things you don't want than count things you do want. So what we could do is this, say, all right, look, there's 360 ways that it begins with 2 S's. I don't want it to begin with 3 S's, right? If it begins with exactly 2, then it can't begin with 3. So how many ways begins with 3 S's? So S-A-U-S-A-G-E-S. Okay, S's are gone. What do we got? 1, 2, 3, 4, 5. 2 of them are A's. That's 60. 360 minus 60 is 300. So what we're doing is, hey, we got away with 2 S's. That wasn't so bad, right? We chucked out 2 of the S's. We looked at what's left. We'd had to divide by 2 factorial because there were 2 A's. Then when it asked for exactly 2 S's, we said, well, exactly 2 S's means it doesn't begin with 3 S's. And 3 S's, like 2 S's, is pretty easy to figure out, right? Get rid of all the S's. What's left? 5 letters. 2 of them are the same. So 360 begin with 2 S's or 3 S's, right? 2 or 3 S's is the 360. 60 of those begin with 3 S's. Get rid of them, and we are left with the ones that begin with exactly 2 S's. So sometimes counting what you want this way is harder than counting the thing you don't want and just subtracting it from a number you already have. Well, pathways. How many different pathways can you take to get from point A to point B while always going east or south? So if we count, you could go to here, and then here, and then here, and then straight down. So that's one path you could take, right? Walk all the way along the top, or we've got directions, right? So north, south, east, west. Go all the way east, and then all the way south. That's one path. You could go all the way south and then all the way east. That's a second pathway. You could go east and then south and then east and then south and then east. That would be a third pathway. You could go south and then all the way east. You could go south and east and south. Okay, wait a second. This is starting to get a lot, right? So no matter how we go from A to B, how many blocks are we going to have to cover? So we got 1, 2, 3. Try to change your answer. 5. So we got to go 5 blocks, right? Does it matter if we go all the way there? What about going 1, 2, 3, 4, 5? No, we're always going to cover 5 blocks. How many of those blocks are going east? 3. How many of those blocks are going south? 2. So in essence, we're going to make up a word that consists of 3 E's and 2 S's. And that word is going to tell us where to go, right? So E-E-E-S-S says go east, go east, go east, then south, then south. S-S-E-E-E would say go south, then south, then east, then east, then east. So we have to cover 5 blocks in total. 3 of them are east. So 5 blocks in total is 5 factorial. 3 blocks east, 3 E's divided by 3 factorial. 2 blocks south divided by 2 factorial. 5 factorial divided by 3 factorial, 2 factorial is 10. I cheated, right? Because 5 factorial over 3 factorial will just be 5 times 4, right? The 3 factorial is going to cancel. 2 factorial is 2, so 5 times 4 over 2 is 5 times 2 is 10. You could do it on your calculator, fine. Just make sure if you're doing it that way, put brackets around the 3 factorial, 2 factorial. Or you'll end up with 5 factorial divided by 3 factorial, then you'll end up multiplying by 2. And all of a sudden, you'll have 40 instead of 10. So the number of pathways is n plus m. So we're only going 2 directions, right? It's a rectangle. You only go left, right, or north, south, or whatever. So m plus n, how many blocks? How many of them are all one way? How many of them are all the other way? So Mrs. K's house is 8 blocks north and 2 blocks west of the Starbucks. How many routes can she take? So don't memorize this. You don't need to memorize this, right? She's got to go 8 blocks and then 2 blocks. So she's going a total of 10 blocks. 8 of which are north and 2 of which are, she lives 8 blocks north, so she's got to go south. And she's got to go east. So 10 factorial over 8 factorial, 2 factorial, which is 45. And if it isn't, leave your answer in the comments below. How many different routes are there from A to B? So let's think about that. Let's say you live in an apartment building downtown, you work over in Kensington, so you got to go over the bridge. So your apartment building downtown is on this grid. There's the bridge, and then where you work in Kensington is on that grid. So think about, all right, so first we have to get to here. So I'm going to have to go 1, 2, 3, 4, 5, 6, 7 blocks to get to the bridge. Let's call that C and say from A to C will be 7 factorial over what? What are the magic numbers? So 5 factorial because we're going 5, and 2 factorial, and that is 21. If it isn't, let me know. Or let me know in the comments below. And then you got to go from C to B. So you're going 1, 2, 3, 4, 5 over what? 3 factorial, 2 factorial, which is, if it's still the same as it was up there, 10. And now we have to decide what to do with the 21 and the 10. So we can add them or we can multiply them, right? So if we add them, what word is associated with addition? Or. And if we multiply, what word is associated with multiplication? And. Okay, so describe to yourself, I'm going to go from A to C or C to B. Does that make sense? Is that what you would tell me? I'm going to go from A to C or from C to B. So are you saying, I'm going to go from A to C and then from C to B? Which one makes more sense? The and, right? I'm going to go here and then here. It's not or. Or is either I'm going to do this or that, but not both. Or maybe both, but it's and. I'm going to go from A to C. So what operation do we use? Multiply. So think of it this way. For every one of the 21 ways that you can get from A to C, you then have a total of 10 paths to go from C to B, right? So for every one of those 21 ways, then there's 10, so you're going to multiply that, okay? Not add. So just ask yourself, and again, just put it in English to say, I'm going to use or, I'm going to use and, which one makes sense? How many different routes are there from A to B if you are always moving away? And when we do this, we're always going to get closer. You're never backtracking. It's not family circus. Yeah, Billy's going off on some path. We always want to get closer. Okay, give this one a shot. You try it. I'm going to pause. So we have to go from A to C, which is 1, 2, 3, 4. And 2 of them are, whatever way that is, east, and 2 of them are south. And then, so I always stick then with and, right? I mean, or stands on its own, but with and then we're going to go from C to B, which is 1, 2, 3, 4, 5, 6 over 3 factorial, 3 factorial. Okay, which is, so that's what, 3? 3. No, that's 6. This is 6. And this is 20. Okay. Anybody get 1 point? Hey, good enough for me. You might be wrong, but if nobody else is doing it, then you're right. All right, we're done. This one. Did I start it up again? Oh yeah, it's running.